We have already learned about modes of asexual reproduction and the three phases of life in sexually reproducing organisms. Today, we are going to start with events in sexual reproduction. There are three events in sexual reproduction: pre-fertilization events, syngamy and fertilization, and post-fertilization events. Among these three, the most important event is the syngamy and fertilization. The most important event is the second one, syngamy and fertilization. All those events which take place before syngamy and fertilization comes in the pre-fertilization event category, and all those events which take place after syngamy and fertilization are known as post-fertilization events. Can you think about syngamy and fertilization? Are these two terms same, or is there any difference between these two terms? Syngamy is the fusion of male and female gamete, and fertilization, if you take fertilization, it includes syngamy and all those events which leads to syngamy. Okay, now as it is seen in the mind map, pre-fertilization events are in turn divided into two: gametogenesis and gamete transfer. Gametogenesis, the genesis is a Greek word which means formation of something. So here it is the formation of gametes, formation of haploid gametes. The process of formation of haploid gametes is known as gametogenesis. And gamete transfer includes the mechanisms for gamete transfer. The first event in pre-fertilization is gametogenesis. As I told before, it is a genesis of gametes. It is a process of formation of haploid male and female gametes. Now these gametes can be homogametes or heterogametes. Homogametes means gametes which are similar in size and shape are said to be homogametes. It has got another name also, isogametes. That is what is given in the bracket. Okay. And gametes which are dissimilar in size and shape are referred to be heterogametes. Can you open your textbook? Page number 10, figure 1.5. Figure A shows isogametes of cladophora. You can see there is the male and the female gamete almost looks the same. There is no difference. Okay, so it is homogametes. They are said to be homogametes or isogametes. Now you look B and C. It is examples of heterogametes. B shows the heterogametes of an alga. The name of the alga is fucus. You can see the male gamete is very small and the female gamete is big. Now C is heterogametes of Homo sapiens. There also you can see the female gamete is very big, it is ovoid in shape. When it comes to the male gamete, it is small and it is cylindrical in shape, tapering towards the ends. If the parent body is haploid, gametes are formed by mitosis. And if the parent body is diploid, gametes will be formed by meiosis. Okay, hope you know what is this haploid condition. Haploid, we write it as N. When it comes to diploid, we write it as 2N. If it is triploid, we write it as 3N, where N is the number of chromosomes. Okay, gametes will be always haploid. Is it clear? Now, there is another differentiation also given over here. The organism can be homothallic or monoecious or heterothallic or dioecious. That is, homothallic or monoecious means it is a condition where both the male and female reproductive structures are seen in the same organism. It has got another name also, bisexual. Homothallic, monoecious or bisexual. Okay, all the three are the same. Now, heterothallic or dioecious or unisexual condition where Male and female reproductive structures are seen in two different organisms. There will be a male organism and a female organism. Two male and female reproductive structures will be seen in two different organisms. Hope it's clear. Open page number 12, figure 1.6. The figure shows diversity of sexuality in organisms. In figure A, you can see the bisexual animal earthworms pic is given. LS of the animal is given, their testis and ovary is labeled. So clearly it is understood that it is a monoecious or a bisexual animal. Okay, the term homothallic and heterothallic is usually used to mention the sexuality in plants. When it comes to animals, we use the terms monoecious, dioecious, bisexual or unisexual. Homothallic, heterothallic, these terms are usually used to mention the sexuality in plants. Okay, now B, it is a unisexual animal cockroach. You can see the male cockroach and female cockroach there. C, monoecious plant, Tara. Okay, in the diagram you can see the female sex organ, Oogonium, and the male sex organ, Antheridium, is seen in the same plant. D shows the dioecious plant Marchantia, it's a bryophyte. Okay, separately there is male and female thallus. Thallus, hope you know what is the meaning of thallus. Thallus means plant body. Okay, and the last figure E is of the bisexual flower sweet potato. Hope it's clear. Go to the next page. You will see this table. You can see the table with the chromosome numbers in neocytes and gametes of some organisms. You have to fill the blank spaces. Okay, the table has got three columns. In the first column, name of organisms are given, and in the second column, it is chromosome number in neocyte, and third column, it is chromosome number in gamete. Neocyte will be always in the diploid condition in 2n, and gamete will be in the haploid condition. Now, what is this meiocyte? Meiocyte is a cell which differentiates into the gamete through the process of meiosis. Okay? I'll repeat. Meiocyte is a cell which undergoes differentiation and forms the gamete. And gametes are always formed by the process of meiosis. Is it clear? Meiocyte will be always diploid in condition and gamete, as I told before, in haploid condition. So, come and fill the blank spaces. You can see the meiocyte of human beings. That is a chromosome number in the meiocyte. If you take Homo sapiens in human beings, the meiocyte in man is spermatogonium, which undergoes meiosis and forms the spermatozoa. And the meiocyte in females is known as the oogonia, which undergoes meiosis and forms the ova, egg. Okay, so look the table. The first organism given is human beings. Meiocyte is 46, and in gamete, the number of chromosomes will be 23, just the half. The housefly, it should be 12 in meiocyte, and in gamete it will be 6, isn't it? Now rat, gamete number is given 21, so meiocyte will be 42. Dog, meiocyte's number is given 78, so gamete just the half, 39. Next cat, gamete number is given 19, meiocyte number will be, the number of chromosomes in the meiocyte will be double, 38. Fruit fly, meiocyte is 8, so gamete half, 4. Ophioglossum, gamete, the number of chromosomes in the gamete is given 630, so meiocyte will be 1260. Apple, meiocyte is 34, so gamete, it will be 70, isn't it? 70, yeah, 70. Now rice, gamete, it is 12, So oocyte it will be 24. Maize gamete it is 10. So oocyte it will be 20. Potato gamete 24. Oocyte it will be 48. Butterfly oocyte 380. So gamete will be of 190. 190. Onion oocyte, the diploid condition is not given. Gamete number given is 16. So oocyte will be 32. Okay. The first event in pre-fertilization is gametogenesis, that is formation of gametes. Once the gametes are formed, then the gametes need to be brought together. Only then the syngamy, fusion will take place, isn't it? So, for successful fertilization to take place, gamete transfer is something very important. The male and female gametes need to be brought together. Only then syngamy, fertilization will happen. In some organisms like algae, if you take both male and female gametes have got flagella and all, so they will move and they will come together, they will come close and the process of fertilization will happen. In some organisms, male gametes, in most of the organisms, male gametes are motile and female gametes are non-motile. Clear? In higher plants, pollination is a method of gamete transfer. In low classes, we have learned about pollination, isn't it? Pollination is a transfer of pollen grains from anther to stigma. And there are pollinating agents, are there, winged, water, animals and all to carry out the process of pollination. So it is a pollination is the method of gamete transfer employed by higher plants. And always the number of male gametes produced will be more than the number of female gametes produced because there is a chance of loss of male gametes during the gamete transfer. Okay. Now when it comes to dioecious animals means unisexual animals where there is male and female organisms, separate organisms are seen. In dioecious animals, there is a special mechanism for gamete transfer to take place. Okay, that you will learn later. Okay, we have learned about gamete transfer. Now next, once the gametes are transferred, the next step is the gametes need to fuse together, isn't it? Syngamy has to take place. Okay, the fusion of male, already I have told about the difference between syngamy and fertilization. Syngamy is a scientific terminology for fusion of male and female gamete. Okay, and fertilization includes syngamy and all those events which leads to syngamy. Hope it's clear. Okay, now in your textbook, another term is also mentioned over there, parthenogenesis. That is in some organisms like honeybees, in some birds like in turkey and all, the female gametes develop into a new organism without the process of fertilization. Normally, the female gamete has to fuse with the male gamete to form the zygote. That zygote will turn into an embryo or turning into a new organism. Here, what happens is the female gamete will not fuse with the male gamete. It will directly develop into a new organism. This process is said to be parthenogenesis. Okay, parthenogenesis is also known as archenotopy. Okay, I know you are hearing this term for the first time, but I don't have a board here to write the term. I'll just spell the term Archenotopy. Archenotopy. I'll repeat Archenotopy. Okay, parthenogenesis or archenotopy. Okay, same thing when it happens in plants. What do we say? Parthenocarpy. Isn't it? This you have learned before. Formation of fruits without fertilization is said to be parthenocarp. Okay, that is in plants. When it comes to animals, we say it as parthenogenesis or archenopause. Clear?